Gravity loads acting on a structure can be divided into several categories. Two of those categories are dead and live loads. So in this problem, we're going to determine self-weight, which is a dead load, of a floor slab and beam. We're going to determine the appropriate live load based on the usage of the structure. The key concepts we're going to go through are what are dead and live loads and how to calculate them. We're going to convert distributed surface loads into resultant line loads. So here's a description of the problem. We have a precast floor beam. It's made of normal weight reinforced concrete, and it's to be used for a floor in an office of an office building. We want to calculate the dead and live loading per foot length of the beam. Now this is a sketch of the cross section of the beam, but it has a third dimension. So if we draw this cross section in an isometric view, you can see the third dimension of the precast beam. Now the loads we want to find are going to be converted into a resultant line load acting along the beam, or acting per foot length of the beam. The two loads we said we're going to find dead load, and for this case that's the self-weight. And we're going to find live load. In the case of an office building, we're talking about things like furniture, people, files, etc. Let's calculate the dead load first, but to do so we need the density of the concrete. Table 1-2 has densities for a variety of structural materials. Since the precast beam is reinforced and it's made of normal weight concrete, it's under the category of concrete reinforced stone, and the density is roughly 150 pounds per cubic foot. Okay, so to get the dead load, we know that the density of the concrete, 150 pounds per cubic foot. What we want is the resultant line load, and we'll find that by multiplying the density by the cross-sectional area. So all we need is the cross-sectional area of the concrete. And we're going to find that by dividing our cross-section into two parts. We'll have the slab part up above. We'll have the stem down below. So we need to add the area of the slab to the area of the stem. Slab area is a ½ foot thick, 4.5 feet wide, so it's 2¼ square feet of concrete in the cross section. Area of the stem, well, we have a trapezoid, so we'll take 1/2 times the width at the base, ½ foot, plus the width at the top of the stem, 1.5 feet, times the height of the stem, 2 feet. Put all of those together, we get 2 square feet of concrete. So my total area cross-sectional area of the concrete beam and floor is 2¼ square feet plus 2 square feet, 4¼ square feet, which means that my resultant line load, 150 pounds per foot cubed, times 4¼ feet squared, 638 pounds per linear foot. To find the resultant live line load, we need the appropriate live surface pressure. Minimum live loads for various structural uses are listed in Table 1-4. For office buildings, there's a different anticipated live load for lobbies and offices. We're dealing with an office, so our design live load is 50 pounds per square foot. So our distributed surface live load is 50 pounds per square foot. To find the resultant line load acting along the length of the beam, we need to take our pressure, our distributed surface load, times B, the tributary width. And for this beam, is 4.5 feet. So we have 50 pounds per foot squared times 4.5 feet, which gives us 225 pounds per foot of length. So our summary is that the distributed or the resultant line load due to dead load, the self-weight of the beam, 638 pounds per linear foot. The resultant line load due to live load, occupancy of the office, is 225 pounds per linear foot. And remember, that acts down the centroid of the beam. Now let's review what we've done. So the problem was we have a precast floor beam made of reinforced concrete. We were given the cross section. We're asked to find the resultant line load that acts along the centroid of the section. We needed to find the dead load, which is the self-weight of the concrete beam, and the live load, which is due to the occupancy. To begin, we need to know what the density of reinforced concrete is, and for normal weight, that's 150 pounds per square foot. We combined that with the cross-sectional area of the section, found that the dead load, resultant line load acting along the length of the beam, is 638 pounds per foot. To get the resultant live line load, we need to know what the occupancy is, what the use of the structure is. And for an office, we found that to be 50 pounds per square foot surface pressure. Combine that with the tributary width, and we found that the live resultant line load is 225 pounds per linear foot.